All right, what's up? Just starting a new one here today. First, before we get started into today's home or a new section, last night, I know maybe some of you had some issues with what we did yesterday with 11.1. So if you ever have any questions, don't be afraid to ask. Number one, just text me or whatever, and I can try to answer them. Also, uh, since it's not due officially until tomorrow, Wednesday, I will make available tonight a little study period that will help you with the quiz. So if you have any questions over last night or what we're going to do today, you can join in a little meeting tonight that will help you. So you can look for that link on the Google Classroom page. Also, I graded your test, your Chapter 10 test, and I will text you individually how many problems you got wrong. And I also uploaded a copy of the Chapter 10 test. So I'll text you individually the questions you missed. And if you wanted to do test corrections, you can just print out the copy of the Chapter 10 test and do the problems that you missed over. And then we'll count that as like test correction. So that's how we'll do the test corrections. Those will be due Wednesday, April 1st, which is kind of when our next official class period is supposed to happen. So, I mean, I guess after spring break, whatever. So have the test corrections done by then. All right. I think that's all the announcements. Don't forget homework from yesterday, 11.1, and today, 11.2, is due tomorrow, Wednesday. And we're also meeting live at 9:30 tomorrow to take the quiz. So be ready for that. And then again, if you need help with any of those, I'll make myself available tonight. Let's say at 7 to have like a little online session for those that need extra help. You notice I changed my background today. You like that? It's where I'm at today. Maybe that should be the extra credit on the quiz. Where am I today? In fact, that will be the extra credit on the quiz tomorrow. Where am I today? I'll give you a hint. Today, I am not out of the country, and I am at the place where golf was meant to be played. So find out the answer to that. That will be the extra credit question on the quiz. A little fun for today. All right, so let's get started with today's section. So I'm going to switch over to the iPad. So I think the way that I'm going to do today is I'm going to kind of list all the things that you need to know for today, and then you can write that down. And then I'm going to kind of go over why we are using it the way that we're using it, or kind of like, I guess you could say kind of like the proofs of the formulas for today. And then I'll do some examples. So again, if you're the person that is like, just tell me what I need to know, that will be at the first part. And if you're more of the person that says like, okay, yeah, that's what I need to know, but why did you get that, or how did you do that? Then that will be kind of the middle part, and then I'll do some examples at the end. So that's kind of how we'll go with today. So 11.2, page 638. We're actually starting on page 639. So if you've got the textbook downloaded, you can flip to that page. Okay, so the first thing that we're going to need to know is the area of a triangle. So here is the formula for that. So the area of the triangle, which you should know, is 1/2 the base times the height. So if you ever need to find the area of a triangle, that is the formula. 1/2 the base times the height. B stands for base. That's a B, not a 6, times the height. Okay? So that's the first thing you need to know. The second thing you need to know is if you're trying to find the area of a trapezoid. So the area of a trapezoid is equal to 1/2 the height times one of the bases added to the second base. So that is the area of a trapezoid. That's how you're going to find that. You're going to take 1/2 the height times the two bases added together. All right, B1 plus B2. That's the second thing. The last thing is to find the area of a rhombus. And to find the area of the rhombus, you're going to take 1/2 diagonal 1 times diagonal 2. Okay, so if you think of a rhombus, which is kind of like a square, but they're not 90-degree angles, you draw the diagonals. We'll show you this, and you times them to get together and divide by 2. So let's just kind of draw these out separately. So if I had a triangle like this, and this would be the base, obviously, this is the height. So 1/2 the base times the height. A trapezoid, which looks, as you know, something like that. I would take, if this was B1, B2, and then I have to find an altitude there like that, that's the height. So that's a trapezoid, and then a rhombus looks kind of like that. And then I've got like D1, D2. Okay, so like that's kind of confusing, but that's diagonal 1, that's diagonal 2. All right. So that's the stuff that you're going to need to know for today. In addition to that, the distance formula you'll need to know. So we'll put that in here for you just so that you have it. You'll need to know that. What else do we need to know? I guess you might need to know like point slope formula of a line. We did that a long time ago. You might need that. You may or may not need that. You'll understand that here in a second, but that's what you should have down for today. Okay, so it's just about how do we use that information. That's what we're going to do next. Okay, but let's start with the first thing, like how did we get these formulas, and just maybe so it will make a little sense and make it a little easier for you to remember. Okay, so let's say that I had, like yesterday let's just make it simple and say I have a square. All right, we know that to find the area of a square, I would just take the base times the height. Well, if I made two triangles out of that square like this, I have two triangles, one here and one here. If I was trying to find the area of one of those triangles, couldn't I just say, okay, since that diagonal that I drew in there is cutting that shape in half, the square in half, that it would make sense that the area of like the green triangle would be half the area of the whole figure. So if I took half the base times the height, that would give me the area of the triangle. That makes sense, right? That's pretty easy. So that's how we came up with that formula. The next one is the area of a trapezoid. And that, if I kind of drew a figure that looks like a trapezoid, okay, and I cut that in half, all right, because I know that the area of a triangle is 1/2 the base times the height, right? So I have two triangles here again, a green one and an orange one. And I know how to find the area of a triangle. So all I would need to do to find the area of this orange one would be to draw like an altitude to find the height there and take this base, which for now I'll call base number 1. And I'll say, okay, well, the area of that orange triangle would be the half the base times the height, half of B1 times the height. All right, if I was trying to find the area of all of this trapezoid, I would need to find the area of the green triangle and then just add them together, right? Orange triangle, area of the orange triangle plus the area of the green triangle. So I would need to try to find the height of that green triangle. So if I have that and times that by the length of this base up here, we'll call that B2. So then I would have the area of the green triangle. And like I said, if you just add those together, then you would get the area of the trapezoid. So how did I do this? I took 1/2 the height, which by the way is the same in both triangles, right? The height of this figure didn't change. So if I take 1/2 times the height of like that, that would give me the area of the green triangle, and I add that to the area of the orange triangle, I would get something that looks like that. Now that's not what our formula looks like. Our formula, if you remember back up here, looks like 1/2 the height times the bases added together. Well, I have that. I just need to factor this out. You know, like if I had something like 2x plus xy, and I was said, okay, factor that, I'd say, oh yeah, there's a common thing in both of those things there is an x, so I could factor out an x and I would get left with like that. Okay, you learned that in algebra, so we won't take too much time for that, but let's factor this out. I have a half in both things, and I have an h. So I can factor out a half and an h, and I'm left with a b1 plus b2. I just changed the order because b2 was first. Now I just moved b1 to be first. Okay, so that's how I got my area of a trapezoid. I take the two areas of the triangles and added them together. Triangle, orange triangle, which is half the base of that triangle times the height. And then I added that to the base of the area of the green triangle, which was half of that base, which is B2, times the height. That's how I got the area of a trapezoid. Again, if I'm confusing you or losing you, you can always just refer back to this. This is all you need to know. I'm just telling you how we got here. Okay, let's go with the last one, the rhombus. How did I get the area of the rhombus formula? Well, here is a rhombus, okay? And if you remember, the property of a rhombus says that, in fact, I'm gonna draw that a little different to make it obvious. We'll draw it a little more slanted. A rhombus is where all the sides are equal, okay? So it's kind of like a square, but a square has angles that are 90 degrees. A rhombus is just all sides are equal. And if I remember the properties of the rhombus, it said that the diagonals bisect each other. Now, just to make sure we remember, that does not mean that all of these diagonals are the same length. What it means is that this segment is congruent to that segment and that one is congruent to that one, okay? So that is a property that we learned about a rhombus back in the day, all right? So let's take the same idea. If to find the area of this rhombus, if I just could find the area of the orange triangle and add it to the area of the green triangle, I would just add them together and I'd have the area of the rhombus. So I would just need to figure out then what is the base of one of these triangles and add that and times that by half of the height. So let's just throw in some numbers just to make it easy. Let's say that this segment was 4 and this segment was 4 and this was 2 and that was 2, just to kind of make it easy and see what we're doing here, okay? So I'm gonna try to find the area of the orange triangle first. So I would take one, of course, we already know that to find the area of a triangle, it's 1/2 the base times the height. So I'm trying to find the area of that orange triangle. I will take 1/2 the base. What's the base? It's 8, 4 plus 4. See that? It's 4 plus this side 4. Should have done that in a different color. 4 plus 4 is 8. So it's 1/2 the base, I'll even write it that way, times the height, which is 2. All right, so the area of the orange triangle is 4 plus 4, 8 times 2, 16. Half of that is 8. So the area of the orange triangle is 8. What is the area of the green triangle? Well, it's the same numbers. I could do it again, but it's going to be 8. So I'll add those together and get 16. So the area of that rhombus is 16. Now, I could have done that a lot faster by using my rhombus formula, right? Which is 1/2 times both diagonals, which in this case, one diagonal is 8 and one diagonal is 4. So would that have worked out the same? Okay, my area of a rhombus says 1/2 of 8 times 4. 8 times 4 is 32, half of that is 16. So yes, I got the same answer. But you're saying, okay, you still haven't showed me. Well, I did show you why. So I just took, that's how I got my formula for the rhombus. Okay, I just took the area of the two triangles and I added them together. Any questions on that, you can ask me later. But bottom line is, if you don't want to know all that stuff, just refer back to your notes right there and use that information. Okay, so how am I going to use all of this information today? Just tell me how to do it, right? So here we go. Let's get this back up here a little bit. There we go. Okay, start with example 1. It says find the area of the quadrilateral. So I've got this funky shape in here that looks something along these lines, okay? It's not really any, it's just a random shape. No sides are parallel. But what they did is they drew in a line here, and they showed me that I have a line here and a line here. I don't know why I didn't make that a dotted line, but whatever, you see it. Okay, it says this is X, Y, Z, W, G, and H. I didn't do that very good. Let's change it a little bit. There. And that's H and W. Okay, so there is my diagram from example 1. And they give me the lengths of some of these things. It says XZ is 39, so this length right here is 39. And then it told me that HW is 20. And then it said YG is 21. YG is 21. So it gave me the height. And it also gave me the base of both of these triangles. So look at it this way. Let's find the area of this triangle and then just add it to the area of this triangle. All right, so let's just do the math. Let's say, okay, HZ, the base of these triangles, this red line right here, they told us that that was 39. So the area of a triangle is found by taking half the base, which is 39, times the height, which is 20. I'm doing the orange one first. So this was 20. And I multiply those together and divide by 2. 39 times 20 divided by 2, and I get 390. So that's the area of one of the triangles, the orange one. All right, let's go and find the area of the blue one. So the area of the blue one is 1/2 the base, which is still 39, times 21, the height from here to here. We wrote that in there, right there. So now let's do that. 39 times 21 and divide by 2. I get 409.5. 409.5. And let's add that to my other triangle. And I get 799.5. So that is the area of that random figure. All right, so I just kind of split it in half. It formed two triangles, took the half the base times the height of each triangle and added them together. All right, that's example 1. You can see right below that, they give you another example of a kind of a random figure that looks kind of something like this. And they said, they gave you the height of that triangle, and they gave us the height of this triangle to be 8.5, and this one was 10, and the base of this triangle is 13, and the base is 17. I'm going to say that probably some of us are going to have a hard time seeing it, but this is one triangle right here, and this is the other triangle right there. So if I take the orange triangle, add it to the green triangle, I would get my answer. So I won't do it all out, but I'll just set it up for you. The first one would be that, right? Added to the second triangle, the area of the second triangle, like that, and you could do the math and get the answer from there. Okay, so that's how I would find some of those areas of kind of some random shapes. Now, the second one we talked about was a trapezoid, and we just kind of saw how we can use the formulas, plug in the numbers. So I'm not going to do like a basic one, but they gave us an example too, a coordinate geometry one. Okay, so this one is where it might get a little confusing, but we'll just work our way through it. It says find the area of a trapezoid with trapezoid A, B, C, D with vertices -3, 1, 5, 5, 5, 0, and 1, -2. So let's draw it out. Point A is -3, 1. That is point A. And that is -3, 1. Point B is 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right there, that's point B. 5, 5. Okay, point C is at 5, 0. And point D is at 1, -2. Connect the dots. Okay, so there it says to find the area of that trapezoid with those vertices. Okay, well, I got to figure out a way to find the bases. So I've got to figure out how am I going to know how far this base is and how far the length of that base. So that's a distance formula. So we go back up to our distance formula little thing. I'll rewrite it down here so we don't have to scroll up. But that is that, okay? So let's find the distance of each of these segments. So I have the lengths of each of these bases. Let's do that first. Let's do AB first. So AB is equal to this, the square root of x2 minus x1. So let's do 5 minus a -3, which is adding 3 squared, plus y2, which is 5 minus 1, which is 4 squared. So AB is equal to 8 squared, 64, plus 8. 64 plus 8 is 72. All right, so, oh no, I did that wrong. 4 squared is 16. Back up. So I'll just write it out. This is 8 squared plus 16, or 4 squared, 64 plus 16. That is 80. Okay, so AB equals the square root of 80. Let's find the distance of DC over here. DC is 5 minus 1 squared, which is 4, plus 0 minus 2, minus a -2, so 2 plus 0 plus 2, so it's 2 squared. So I get DC is equal to 16 plus 4, which is 20. All right, so I find those two lengths. So there's my bases. One base is the square root of 80. One base is the square root of 20. Now I got to find the height, right? If I just extend this, I mean, I could draw any perpendicular segment in between those two things, and I could find that point, okay? They, in the book, said, okay, let's just extend this one out and then draw a perpendicular segment like this, and I would get this point. So they just said, okay, well, it looks like it's that point there is -1, -3. So then I could use the distance formula again to find the length of the height. So I could do that. Now you're saying like, well, how did I know that? How did I know that that point intersected there at -1, -3? Okay, so, well, we could go through that process, which we will right now. And this is total review. We've figured out we have to find the point at which this line of the height, this one, intersects this line. So I've got to find the point at which those two intersect, okay? So this is total review. And you may or may not need it. I think that sometimes you'll be able to eyeball it and we'll settle with that, but maybe not. So if you can't just look at it and say, yeah, okay, that's where it intersects. So I could find the height based on that. This is how you're gonna have to figure it out. Okay, first, in order to find out where these two lines intersect, I gotta figure out the slope of this line. So the slope is, rise over run. So it went, find the slope of that line, which is, okay, it would be -2 -0 over -1 -5, and that is -2 over -4, which is just 1/2. Okay, so this is the slope of DC is 1/2. All right, no problem with that, hopefully. So what is the slope of the line perpendicular to that? We did go over that yesterday. So if I wanted to find, let's just make this point E out here, this where we're trying to find this, where these two lines intersect to find the height of this trapezoid. I'd say, okay, what is the slope of this line AE? Slope of AE. Well, if things are perpendicular, they are negative reciprocals of each other. So the negative reciprocal of 1/2 would be to flip it over and it'd get 2 over 1, and it's the negative of that, so it's -2 over 1, or just 2. So the slope of AE is 2. Now, to find that point, to make sure it's -1, -3, I need to get equations of those lines. Again, this is all review. We've done this before. So let's find the equation of line DC. So here's line DC, the equation of that line. Like I said at the beginning, we're gonna might need to know the point slope formula. Y minus y1 equals the slope times x minus x1. Come back down here, okay? We'll just rewrite that first. Y minus y1 is equal to the slope times x minus x1. All right, now let's pick the point D. You could use C, but any point on that line will work. But let's just use D since it's easy, 1 and -2. So I'll just highlight these. Here's the X point. Here is the Y point. So let's just put those in for Y1 and X1. So we get Y minus the Y1, which is -2, equals the slope of the line DC, which we found right here, is 1/2. X minus x1, which is 1. Okay, now let's just kind of multiply it out. That's y minus 2, or y plus 2 equals 1/2 x minus 1/2. Now let's put all the like terms on the same side, and here is my equation of line DC. Y equals 1/2 x minus 2.5. I just subtracted 2 from both sides. You can see that, basic algebra. Okay, so there's my line equation for line DC. Now let's do an equation for line AE. So let's do it on this side, line AE. And we'll use our point slope formula to determine that equation. All right, so here we'll just put in what we know. Here is the y, here is the x. So let's put those into this equation. Y is 1. The slope of that line over here we figured out to be -2, and times x minus x1, which is -3. Okay, let's kind of simplify that, I guess. So we have y minus 1 equals -2x, and that's kind of a lot of pluses and minuses there, but that's like x plus 3. So we'll say that is the same as -6, -2 times +3. Okay. All the like terms on one side, add 1 to both sides, and I get that equation. Okay, so now I have two equations. I have the equation for line AE, y equals -2x minus 5, and I have the equation of line DC. All right, so let's just substitute in one of these things for the other. So see in this line right here, this again, this is all kind of review. In line DC, y is equal to this. So I'm going to take this blue and I'm going to put it in right there. Okay, so I'm going to take 1/2 x minus 2.5 and say that's equal to -2x minus 5. Now let's solve for x. So let's add 2x to both sides and I get 2.5x. Let's add 2.5 to each side and I get -2.5 on that side. Now let's divide by 2.5 and I get x equals -1. Okay, is that what we had right here? Oh, look at that. Yes, indeed. X did equal -1. So how do I confirm if the point -1 and -3 are correct? Well, I got to find the y value to make sure that one's correct. So let's just put in -1 for x somewhere. Let's take line DC and just see what y, if x is -1, just plug in -1 for x, what y becomes. So y is equal to -1/2 minus 2.5. Do that on your calculator or just do it in your head. -1/2 minus 2.5 is equal to -3. So there is my point. -1, -3. Oh, look at that right there. That's what we had. So our eyeball did work. A lot of work there, but we've done it before. Okay, so back to our problem. We're trying to find the area of this trapezoid, right? We're trying to find the area of here. And my area of the trapezoid is, the formula for that is area of a trapezoid is equal to 1/2 the height times one of the bases added to the other base. Okay, got that from the top, back up here, right? Right there. Okay, so let's figure out this area of the trapezoid. 1/2 the height. Well, I don't know the height yet. I do know my 2 points now. I've just got to find the distance. So distance formula one more time. Hang on, we're almost done. Let's find the distance of that line. So I'll do it right here. AE is equal to the square root of -1 minus a -3. So -1 plus 3 squared plus -3 minus 1 minus 4 squared. So I get AE is equal to that -1 plus 3 is 2 squared, 4 plus 16. AE is equal to 20, the square root of 20. Okay, so there we go for that one. I've got that. Now let's just plug in what I know. Okay, the height, AE, that's the square root of 20, times base 1. Base 1, it doesn't matter which one, let's say DC. We found out that DC is the square root of 20 right there. That's the length of that segment. Added to the length of the base 2, AB. We found that one over here, right there. That's the square root of 80. Okay, simplify. Let's add those together. Okay, and I get that, right? So let's simplify this some more. Let's say, well, let me back up. Let's back up. Let's go to this. Let's multiply this out a little bit first. Okay, so let's do the square root of 20 times the square root of 20, which is, so see what I'm doing here? I'm going to use the distributive property like that. And so I'll erase this. Okay. So now we have that. Find the square root of each of those things. I get 1/2 times the square root of 400, which is obviously just 20. And I add that to 1/2 times the square root of 1600, which is obviously 40. So I get 10 plus 20 equals 30. The area of that trapezoid is 30. Oh my goodness. Man, it's a lot of work, but we got the right answer. Okay. I don't think you'll have too many of those, but let's do one more example here. All right, let's find the area of the rhombus. It says find the area of rhombus. This is example 3, EFGH. So it graphed it, E minus 1, 3. A lot of distance formula today, I guess. EF27, 3, 4, 5, 6, 7. F27, G53, and H2 minus 1. All right, there's a rhombus, they said. That's a rhombus. Okay, well, if I take I gotta find the length of the diagonals and multiply those together and then take half of that. That was my formula of the area of a rhombus. So the area of the rhombus is 1/2 D1 times D2. Okay, so use the distance formula. I'm not going to go through that to save time, but just find the distance of those two diagonals, find the distance of this diagonal by using the distance formula, find the distance of this diagonal using the distance formula, put in those things there into the formula, and you'll get your area of a rhombus. Okay, so today's homework, and then I'll do one for you, is 10 through 15 all, and then 16 through 29 or 28 even. By the way, in case you didn't see the post, obviously if you printed out the textbook for what I gave you, it has the answers in them. You've got to show all of your work. Otherwise, you can't just put the answer down. Show me your work. So let's just do number 10 real fast, just for fun, just to make sure we're all on the same page. Here is this random figure. It looks kind of like this. Okay, and they drew this into two triangles like that. And they told me that the height of this triangle over here is 5. And then they gave me the height of this triangle right here to be 5. And they told me this length is 8. This length down here is 12. So let's find the area of this triangle, add it to the area of this triangle. Let's do the red one first. The red one has a base of 12 and a height of 5. And if I take those two, add them together, or times them together, and then divide by 2 or multiply by half, however you want to say it, I get 12 times 5 is 60. Half of 60 is 30. That's the first triangle, the red one. The area of the second triangle, 8 times 5, that's 40. So half of 40 is 20. Take those two things, add them together, and the area of that figure is 50 units squared. Okay. Again, if you have trouble tonight, 7 p.m. We will see you later. 7 p.m. if you need help. If not, this homework is due tomorrow. 10 through 15 all, 16 through 28 even. Peace out. Enjoy your time at home. I'm going to hit the links right there behind me. Look at that. Don't go over that green. You might be in the ocean. So, all right. We'll check up with you later. See ya.